Assalamualaikum warahmatullahi wabarakatuh. We are from Group 10, Presentation, Polygon of Forces. My name is Raja Abdul Hadi Putra bin Raja Ismail Idham, metric number AA220740. The objectives of this experiment are: first, to determine either the total of force will be in equilibrium or not when they are put in different directions. Number 2, to expose ourselves to the correct technique on how to draw a free body diagram from the experiment that has been done. Number 3, to be able to draw a closed space diagram from the free body diagram. And finally, to build an apparatus that has a quite similar function as the current laboratory apparatus. Polygon of forces can be viewed as a vector quantity because the force acting has a direction and a magnitude. The direction of each force will act as a vector, while the amount of the force will be counted as the magnitude. A polygon of force is a force polygon formed when there are several forces acting on an object that determines whether the object is moving or stays stationary. Forces acting on objects are originated from various directions. Every force that acts on the object has an angle, either on the x-axis or on the y-axis. An object is in equilibrium when the vector sum of the external force acting on a point is 0. Therefore, the vector equation fx and fy will be equal to 0. As the equation of equilibrium had stated, sum of fx equals to 0, sum of fy equals to 0. This equation can be used when the object is in equilibrium when there are more than one force that acts on it.
Hi, Assalamualaikum. My name is Izul Hafiz bin Mas Azri and my number matrix is AA221156. So, for the concept of polygon of force, a set of force whose resultant is 0 can be depicted by drawing them end to end so that they form a closed polygon. This is called a polygon of force. If the polygon is not closed, there is a non-zero resultant force. A polygon figure the sides of each of which are vectors representing several forces acting same upon the point, so that the vector necessary to make the figure close is the resultance of this force.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Najib Salam. My metric number are AA221635. Alright. For the apparatus for our project polygon of forces, we are using binding tape, ruler, rope, puncher for replacement for a hammer, protector, ring, coins, nails, pencil, scissors, and chopping board. Also, a small plastic pouch bag that we are made from plastic to replace our weight hanger. Alright, for the procedure, firstly, we're gonna to set up the apparatus as shown. Second, apply weight to every weight hanger of the apparatus in the plastic pouch for replacement for weight hanger. Thirdly, the ring will start to move after we put weight coins in the weight hanger. The ring will start move. Then, when the ring stop move, start to take the measurement. After that, insert the measurement in the result table. We are gonna show after that. Then we repeat the step from the second until the step for inserting the result of the measurement in the result table.
Assalamualaikum warahmatullahi ta'ala wabarakatuh. My name is Muhammad Bayhaqi Atiqullah bin Muhammad Zamidi. My metric number is AA220990. As for the result, we had set up a 4 forces and 5 forces experimental setup. As recorded in the result table, we were able to draw a 5 forces and 4 forces force diagram. However, some of the vector force in the diagram does not touch the tail of each other. The shape of the polygon may vary due to inconsistent length of rope and width. The net force of each vector force in the apparatus must be equal to 0, resulting to an equilibrium. From this, we will measure the length of the rope for each force and the angle with respect to the x-axis. This measurement were then used to draw the force diagram, but our force diagram appear to be slightly incorrect because the final vector does not touch the tip of the first vector. This is bad news because the drawing is supposed to be a closed polygon. This happened due to parallel error such as our eyes are not aligned properly perpendicular to the roller and the protector. On the other hand, our hands are not quite aligned to the line when measuring the length using the ruler. Finally, the item we use also are not really suitable for the experiment since they are merely DIY item. To overcome this situation, we should be more careful when taking reading, make more accurate point for the next, and use heavier weight to ensure a proper equilibrium state.
Application. Polygon of force is applied in real life by using them when building bridge and crane. It has also been applied to many sorts of different jobs that require more than 3 forces upon one coordinate. When a task that includes many vectors forces acting on a single point to achieve equilibrium, the principle of polygon of force can be a convenient way to solve the problem. Finding. From the experiment, we can see that forces that act on a single point when being put into correct position in terms of angular position and correct magnitude will be in an equilibrium state. If one of the forces is removed, the whole setup will fall apart due to an imbalance in magnitude and direction of force. In this experiment, the same amount of weight is used for every load, which is 55.52 Newton. Different direction of forces acting on a center point in equilibrium theoretically produce a set of vector lines which can be aligned and merged properly together to form a polygon. If an accurate closed polygon can be drawn by using the vector of forces of the system, which is an equilibrium state, that means the magnitude and angular direction of the force are theoretically and practically accurate.
It can be concluded that via this group project, as a team, we were able to display basic skills and knowledge of polygon of forces using homemade equipments. We also analyzed the data obtained from the experiment efficiently and were able to work as a team throughout the experiment. The law of polygon of forces stated that any number of coplanar concurrent forces can be represented in magnitude and direction by the sides of a polygon taken in order, so then their resultant will be represented by the closing sides of the polygon taken in opposite order. Therefore, to achieve the equilibrium in polygon of forces, the resultant forces must be 0 in order for the system to be sturdy and cannot be easily broken, such as a bridge. Thank you.